Here's a table comparing the speed of an automobile with its mileage. And you might notice that the mileage numbers actually increase as the speed increases up to a point, around 55 miles per hour, it looks like from the table. And then it starts to decrease. That is, the mileage starts to decrease as the speed increases. At any rate, we'll get back to that idea in just a little bit. To enter the information onto the calculator, we press Stat and then press Enter for the Edit menu. And notice that I've already entered the information, and the speed values are given in the first column, and the mileage numbers are given in the L2 column. All right, with these on board, then we can take a look at a scatter plot and see what kind of pattern emerges. Now, to do that, recall that we need to turn the plot on, and to turn the plot on, we press second and then Y equals. And we'd like to turn a plot on. I'm pressing Enter here and then Enter again to turn the plot on. Now I'm noticing that I just want to glance at these things. If we've made any changes in these parts of the menu, we might need to change back, but the type is this first item here, the scatter plot. The X list is in L1 and the Y list in L2. And we're ready to go. Now, to cause the calculator to give us a window appropriate for the information, we'll press Zoom. And then we want item number 9. We could just press 9 or cursor down to it as I've done here, and then press Enter. And here's the information. Wow, it really looks like this information is curvy here. And because of this curved pattern, certainly a linear model would not be appropriate. Kind of looks like a quadratic model would be appropriate to this information and match fairly well. So let's go through and perform a quadratic regression. And to do that, we'll press Stat and then right arrow one time for the Calculate menu, and then go down for the Quadratic Regression model. And pressing Enter here and then Enter again, we get the information. Now, I have diagnostics is on my calculator from our earlier work in a previous section. And notice that the R-squared value is 0.97. That's a fairly decent fit. That is, this model, the graph of this equation, should fit the information fairly well. Well, let's see. To cause the calculator to enter the equation for us, I'm pressing Y equals, and I'd like to enter the equation. And rather than enter the A, B, and C sort of by hand, I'll make the calculator do all the work. I'm pressing VARS, and I'm going down to item 5, Enter, cursor to the right twice. I want the top item, the regression equation, so I'm pressing Enter. And here's the equation. Now graphing, there we go. And sure enough, the graph kind of matches the data points fairly well. Well, let's see. One question that we might answer here, the most logical one, I suppose, is to find out the speed that gives us the highest mileage. Now, remember, the speed values are along the x-axis. These were the items in the L1 column. So this is speed. And the vertical axis is the amount of mileage. So at this speed, and actually I can see it maybe more plainly here if I press trace, these are data points now, and a speed of 15 miles per hour gives a mileage of 22.3. And as I cursor to the right, I get the data points that I entered into the calculator. Now when I press the up or down arrow button, I am jumping onto the calculator, and I can cursor over as much as I want to arrive at the topmost point. Now, the topmost point, though, is a little bit elusive. Gee, I have some very long-winded decimals here. I get 30.42 here, 30.43. I'm a little closer, 30.44. I'm reading the Y values now. And now back to, so it looks like this value right here is as close as I can get without zooming. Now, I might wish to zoom, and it could be that we have a feature on the calculator that will help us find this maximum value. Press second and then the trace button. It's a calc menu or a calculate menu, and the maximum value on the graph can be found by pressing enter here. and now it's asking for a left bound. And really, this kind of request is just allowing the calculator to be in the neighborhood. If I cursor over to the left, I might call this a left bound, so I'm pressing enter. A right bound, I just want to go to the other side of that top point, and I'll press enter right here. And then guess, well, a guess is really not necessary. But once I press enter, it will give me a very exact value for that maximum. We were pretty close to it before. So the maximum value on the graph is at these coordinates, and it means then that an x of 45.49 or 45.5 miles per hour will give a maximum mileage, and that maximum mileage is 30.44. Here's a table which shows the amount of money spent on books and maps in the United States for the years 1990 to 2000. Let's use the information and generate a scatter plot and decide on an appropriate model for the information, and actually generate the model to see how well it fits. Well, let's see. Let's first enter the information, and to do that we'll press Stat, and then to edit we'll press Enter. And notice that the information has already been entered. The important thing here is to realize that in this column where the years would be entered, I have only used the last digit for the years. So this would be 1990, this is 1991, and so on. And so the basis year for our study here is the year 1990. Okay, let's take a look at the scatter plot. With the information entered, we press second and then y equals, and we want to turn the plot on, and I'll do that just by pressing enter here. I'm noticing that all of the other items are on the defaults, and our information for x and y values are in L1 and L2. And now we're ready to look at the scatter plot. Let's make the calculator set up the window for us. I'll cursor down to item 9 here, zoom stat. And here is our information. Now notice that this particular scatter plot isn't as obviously quadratic in nature. That is, the model which will best fit this is not necessarily quadratic. It kind of looks like it could be linear. You see that this could be thought of as linear. It's just slightly curvy here, so maybe a quadratic model is appropriate as well. Let's take a look at both of them. Let's go through the process of calculating. I'm pressing Stat and then the right arrow, and I'll go down to the linear regression model first and pressing enter. I get the linear regression. Wow, it kind of looks like it's a pretty good fit, doesn't it? Because after all, these values are close to 1 for r and r squared. So we might think, gee, we have a pretty good fit. Let's take a look at the graph. We'll press y equals and then make the calculator bring the equation on board. I'm going down here to item 5 and then cursor over 2 and pressing enter, and here's the equation. And now for the graph. Gee, the linear equation, the graph of the linear equation seems to fit fairly well. And but let's go through the process for a different kind of model. How about the quadratic model? Well, let's see. We'll press Stat and then calculate, and now we want the quadratic regression. Here it is. Pressing enter and then enter again. Now, before I press enter again, I want us to notice the r and r squared values here. You see 9.86 here, 9.72. Now we're going to compare that with corresponding values for the quadratic regression. Oh, look, r squared is 0.995, and that's a good deal closer than the value for the linear regression. So this line ought to fit better. This graph ought to fit better. Now, to cause the calculator to bring it on board, I'll have to cursor down here to y2 and then make the request for the regression equation. And to do that, vars and then down to statistics and over to the right too. Now, it's important to realize that this is exactly where we went before to grab the linear model. We go to the same place for the quadratic model. You see, the calculator replaces the previous regression equation each time it makes a new calculation. So now the quadratic model is on board, and here is its graph. And here it comes overlaid with the linear graph. Now, if we just want to see one of the graphs and see how well it fits, we can do that by going back to y equals, and I'm pressing the left arrow button, and with the icon blinking over the equal sign, I can press the enter and now I have deselected this particular graph. And when I go back to the graph, I'll see only the quadratic model, and it really seems to fit the information well. Well, at this point, we could make any number of calculations, the corresponding a year with some amount of money spent on books and maps, but the main theme of this problem was to choose a model and see how well it fits, and we've done that.